Good afternoon, everyone. I'm Dr. Joseph Jemsek here in Washington, D.C. I'm an infectious disease expert and Lyme Borreliosis expert with a very, very large practice here. I think some of you may know that. I'm participating in the AONM conference, courtesy of your organization, and I'm thrilled to be involved again. I think this is my third, maybe fourth time working with Claire, Jillian, and Martin. And I must say that this group has done a marvelous job of getting this together. Obviously, this year is different. With COVID, we're doing it remotely, virtually, whatever you want to call it. I wish I were in London. It really screwed up a trip I had planned to Ireland, London, and Denmark. But I'm happy to participate. The organization has asked me to speak about some of my strengths in infectious diseases, and in this case, it'll be the relationship of COVID with Lyme Borreliosis complex. Now, you have to realize this is my third epidemic. As an HIV provider, I was involved for 23 years, and in Lyme Borreliosis, we're going right at 20 years now, and COVID is the third. And they're all different. I'll have a short comment about that later. But I'm very much involved in the first two, very heavily involved, and not so much in this one. But I think it's incumbent on me to understand what's happening to the Lyme population, the general population as well, in terms of their exposure and consequence of COVID infection. So I've taken it on myself to look at some of the immunology. And with the help of my very good clinical scientist, Sinai Gade, we've put together just a short handful of slides, and then I'll be answering Q&A going forward. I must say I'm very impressed with the audience that I've seen grow over the past couple of years when I've attended the conference in London, and I know the questions are going to be very sophisticated and tough, and I hope I can do them justice. Obviously, we're all involved in a rapidly evolving and volatile and politicized situation with different countries doing different things, scientists going back and forth. I feel like I'm watching a tennis match. But this happened in HIV/AIDS too. It was back and forth, and it took forever to come to some conclusions. Now, I've been following St. Tony Fauci of the NIH, and I honestly think President Trump's been very patient through this whole thing and had a fairly steady hand, but yet he's being politicized and criticized to high heavens. And I'm sure the same thing's happening in the UK and on the European continent. So we're going to do our best. We'll just put a couple things in there. If we can come out with one solid and simple and safe recommendation, I think we've done our job. The title of the talk is Lyme Borreliosis Complex and COVID, How Do They Interact? And on our next slide, we have a model that we created last year to look at the general process by which disease happens. And if you look at the slide in the middle, in red, we have viral infection by COVID. That doesn't have to be COVID. It could be another precipitant, another infection, but in this case, we put COVID in the equation. So, I've thought about this for a long time, and this has to do really with Lyme Borreliosis. Why do some people get sick and other people not get sick? Why do some people recover more quickly than others with viral illnesses and other illnesses? Why do some people live a lot longer than others and others not so much? Why do things run in families through genetic patterns, presumably, and other families are spared? We don't live in a Darwinian society anymore, so it's not survival of the fittest, but we still have vulnerable populations. So if you look at the slide, I hope you enjoy this. At the top, I have three major categories, including lifestyle environment, and Lord knows what's in our environment. Do you realize there's 1,000 new chemicals put in our environment every year? Do you think that's good for us? Do you know how many mistakes have been made in terms of companies, chemical companies, biologic companies putting things out there, sort of understanding what happens first generation, but not so much second, third, and fourth generation. Then we have genetics, which is, I think, key. As we go down, we talk about under lifestyle, we talk about, and since this is a Lyme-based population, everyone knows what a low inflammatory lifestyle is. But we talk about all the stressors, acute, episodic, chronic, and we talk about self-medication and abuse, whether it's alcohol, drugs, tobacco, or just a horrible diet. And then under environment, we just put mold and toxic environment because we didn't know what else to put. And under genetics, we have single nucleotide polymorphisms, which have to do with the DNA code, and where none of us has a perfectly normal or natural, non-substituted code. And so where those changes are make differences in how we handle and process antigens, how our cells are managed on a daily basis, and how we fight disease. And coming together under that, I put COVID, not because it's in every equation, but I just put that in there as an accelerant, as something that would further compromise the immune system, for example, or the host. And then off to the right, we talk about HLA, or human leukocyte antigens, which are cells expressed on, or which are molecules expressed on all of our cells. And there are three classes: major histocompatibility complexes. And the second class is probably the most important for immune response. And under that, Sinai and I have identified, and Sinai, by the way, does quite a few 23andMe analyses, so he's had experience with a couple hundred reviews and has gotten very familiar with these haplotypes. But I have listed a few. We don't need to go through them now. I have a slide later. Then under COVID, in the dark, I have POEMS, which is an acronym for pain, other being comorbidities and in particular support, endocrine, particularly the adrenal gland, and the effect on the pituitary, at least in Lyme borreliosis, mood, very important to be stable enough to be treated, and sleep, which is absolutely essential to neuroregeneration and health of the brain, where we rinse our brain at night during deep sleep. And those are categorized off to the right. Now, if bad things are happening from the top down, we're going to see the disease expression. Now, with Lyme borreliosis, you have to understand, I look at the world differently, and I'm pretty sure I'm right. I know that sounds cocky, but I've seen 13,000 patients, and you haven't. And I'm not deriding you. I'm deriding the doubters, the haters. But what we see is that there's almost in everyone a confluence of adverse stressors as compensatory mechanisms deteriorate, whether it's sleep or there's too much pain. And it's all about the immune system. It's all about the immune system. And when you have these constant stressors, or you have 24/7 inflammation from Lyme borreliosis, or a subacute attack with COVID, or anything else for that matter, the immune system's under assault and needs to be strong and firm. And as we age, it weakens. So we'll get into that in a little bit. In the following slide, we have a little bit about COVID and the receptors. I think most people are familiar with the angiotensin converting enzyme 2 receptor. And, the longer I'm in medicine, the more interesting it becomes, because, things I learned about, I thought this was just a renin and angiotensin dependent enzyme. These are receptors, by the way, that was important in regulating renal volume and eventually blood pressure, salt retention, etc. Turns out it's all over the body. And if you look at the bar graph, and you'll see And I know that's really hard to see. I apologize. But virtually every organ has receptors. Surprisingly, the most receptors are in the gut. And maybe not surprisingly, because we know that 70% of the immune system sits behind the lamina propria in the gut. The lung is not so much as you would think, but it is the portal of entry for COVID. So we've listed that the virus itself is RNA-dependent RNA polymerase, and that's a certain type of RNA viruses, DNA viruses. We don't really have effective vaccines against RNA viruses. HIV/AIDS, 39 years and counting. Ebola, SARS, some of the others still not developed. So it's tough. And as an aside, I would say it's totally unrealistic to think we're going to have a vaccine anytime soon. And I'm totally against rushing it through and doing limited clinical trials and then putting it out to the public. I am totally against that. I think that's capricious and hazardous and very much ill-advised. So we just got a brief list of all the medications, and you're familiar with some of these. Interesting politically to see which ones get pressed at which time. I don't understand the hostility to hydroxychloroquine, unless it's the old pharmacy trick or pharmaceutical house trick of, well, it's so cheap we can't make any money, or we don't have that drug, or whatever. I don't know. Here's the deal. I wish that if 70 people were making vaccines, just get it together and work together, work as countries together. When HIV was recognized to be a revolting, horrible epidemic in the late 80s, our government somehow, actually I think I know how, but it's not pertinent to this discussion, created ACTG sites. So there were a handful of sites, predominantly in the Northeast, where scientists were just put in the building and said, do the work, do the grunt work. It wasn't sexy, but we got some very fundamental basic information about the retrovirus, HIV. In our following slide, this is just a real quick overview, so this is easy. The second bullet, the thrombophilia, is important, and we'll refer to that later. But there's been encephalopathy, there's been cardiomyopathy, kidney failure, but predominantly in pneumonia. Predominantly it kills by attacking the lungs. It doesn't attack it in a customary way, and I'll talk about that in a second. And again, this is just with the more severe cases, which are hospitalized, and that's a small fraction of our patient population. Of course, that's concentrated mostly in the elderly. But there are, as everyone knows, young, healthy victims of this illness. And the question is, why are they susceptible? And I think the goal should be to have some sort of screening test, if possible, a quick screen, to say so-and-so is vulnerable to having adverse effects from COVID at age 35, based on this simple blood test, or based on a key piece of history. In other words, let's target our efforts instead of quarantining everyone. Now, I know the securing everyone and seems to have flattened the curve, etc. It's going to broaden the curve, of course. But we don't know so many things about this disease. It's new. We don't know how many people develop antibodies, whether they're protective or not, and if they are, how long they last. We've had numerous reports of people having been tested positive. I think the swab tests are probably okay if done. It's mostly a technique issue. But then I also think that we've had recurrences or relapses in those people, are reinfections. Now, I think everybody thought at first these are reinfections. I think they're reactivations. I don't think the immune system kicked it out, especially in a mild case. That's worrisome, isn't it? And it begs the issue, is this going to be a chronic recurring infection, endogenous? Is it going to be one of our new endogenous residents, commensals, that has some pathogenic potential, like CMV, like the herpes viruses, like Lyme? So here are some facts everyone knows, so I won't spend a great deal of time on this. But we try to go through some of the immunology. What happens as we age? Well, the thymus shrinks up, and naive cells, T cells, can't regenerate, can't keep up, and proliferative activity diminishes. Before I go too much further, we have two main lines of defense in our immune system: the innate immune system, which is on the front end, and consists of macrophages, monocytes, mast cells, eosinophils, and is responsible for capturing antigens, but it's mostly responsible for antigen presentation or delivery to the more efficient and sharpshooting and permanent system, if you will, the adaptive immune system. That's the system that dwindles with age, and we'll get into that a little bit. And I think without question, in the Lyme population, the same thing happens. The old adage about Lyme patients don't get colds? Well, it's because the immune system is hyperactive and doesn't present the antigen to the adaptive system, and never gets the signal from the adaptive system to turn off. And so we always laugh here and sort of celebrate when somebody gets their first cold in 4 years. And I think that story holds up very well. Same thing in the elderly, and that is going to play into what we're going to talk about in a moment. Genetics, I'm going to reiterate that we have major histocompatibility complexes, areas 1, 2, and 3. 2 is the most important for the immune system. Underlying conditions, obviously, predisposed patients, and anybody who's immunocompromised is going to have some problems, more so than the general population. On this particular slide, I don't expect you to follow it all the way through, but I just did want to point out that these are some of the more critical genes involved in immune regulation. And if you know anything about 23andMe and you know anything about methylation, you know that we all have SNPs, or the single nucleotide polymorphisms. Everybody has them. They're spotted throughout. I've never seen a perfect one. And Sinai has done a couple hundred of these, made some nice observations, which I'll point out in a minute. So none of us are perfect, which doesn't matter as long as we're not inflamed. But with Lyme borreliosis, for example, we have an inflammatory storm, and those enzymes, those genes, if they're not functioning fully, in other words, if they have one substitution, that's called heterozygous. If they have two, there are two alleles, that's called homozygous. If you have one substitution, your enzymatic activity may vary from 40 to 70%, let's say. If you have two, it's maybe 20 to 40%. And that's good enough, to keep things moving on down the track, unless you're chronically inflamed. And that's why our Lyme borreliosis patients are under such assault. They can't compensate. And so we do everything in our power to make recommendations based on the genetic patterns in terms of supplements, food avoidance, perhaps exogenous B12 injections if they have an issue in the methionine cycle, for example, and so forth and so on. Same thing here. Probably the most important genes are the HLA-DQ genes, where we have A1 and A2. And there's highlight in the third bullet, which says that variation can lead to a delay in presenting foreign antigens to the immune system. Remember I said that antigen presentation was so important? This is important. And we think this is a clue to why a subset, in the population, probably with multiple areas of change, not just this particular gene group, but probably in multiple areas. And we don't know that. That's what I'd like to do, a quick test on people, if that's going to be ever possible. I think it could be done, but I think that is very important in terms of delaying the adaptive response. On the following slide, we have a cartoon here, which is our own invention. This is the Generation 1 cartoon, so don't be critical. We can make it better. But I had the idea that, let's say we're in our home and we happen to have a gate. Not many do, but let's say we have a gate. And we've gone medieval here. And let's say the house sits back and has a front porch. Even has some guards on the front porch. The correlation here would be that the virus is at the gate, the barbarian's at the gate. And we have a strong innate immune system, which can keep some things out by itself, even though it's not getting any help on the backside. Perhaps with coronavirus, it can't do it quite as well, speculate. And so it's a two-pronged system. You know, the innate system processes things, stops most of it, delivers it, and gives it to the sharpshooters, the adaptive system, the T cells, which then communicate with B cells, the humoral system, whereas the T cells are the cell-mediated system. The B cells then communicate with plasma cells, which make antibody. Okay, so it's a very intricate system, requires durability, requires endurance and strength. But in our example here, COVID gets through. There's nobody awake on the front gate. There's nobody to stop them. There's no focused reaction, and COVID gets in the house and burns down the kitchen. Game over. So this can happen one of two ways. It can happen through natural aging, and it can happen through unique susceptibilities that we just described, which are yet to be determined. But I think we're onto something. Incidentally, Sinai has identified, and we're very excited. In his analysis, he's finding HLA-DQ A1, A2 mutations in the majority of our Lyme borreliosis patients. If we can find what the general population incidence is, that's going to be very exciting to know, well, why some of our Lyme borreliosis patients get quite ill and why others don't. Because I'm a outlier, I guess you'd say, but I think I'm quite sure I'm right. I think everyone has the spirochete, right? And I've lectured about this before. We all have the spirochete, so it makes a difference. Well, other pathogens have to come in, mainly Babesia, which is a topic for another day. But, and all the factors I talked about, if you go back to the slide with the environment and genetic variability and lifestyle, et cetera, et cetera, et cetera. And then the POEMS, remember POEMS, P-O-E-M-S? So we think that, and we did our research on the elderly. This is what happens. They lose their adaptive immune system potential, but the innate immune system, they lose much less. And we think that's a key reason for their vulnerability, in addition to, of course, other illnesses and other types of inflammation in the elderly. In the following slide, Claire sent me a list of questions and said, you know, what are the some of the differences? And so we just did a real quick checkbox. And since I'm the veteran, I'm the only veteran of all three pandemics, and I can't take too much credit for this one, but I certainly involved in the first two. And here's what I saw. And so if you see, we have in the left column HIV/AIDS, COVID, and Lyme. And then we have categories of activism, research, and wealth and resources. So HIV/AIDS started off slowly, but then got a ton of money as it became obvious that the government was being by that time, gay activism was in full swing, and the government felt compelled to do something. And I think there were gays in the government that helped compel that. And going back, I think that's why ACTG sites started so early in the late 80s, which was great for the scientific world. Lots and lots of organized activism. AIDS got a ton of research. Oh my God, there's been 1.5 million papers written. And in terms of Lyme, it's not a good picture because, you know, after 1 million articles, they're still arguing about when to, what CD4 level to start therapy. And then finally, lots of money, which goes hand in hand with the research. So there's research both on the private level, many countries, both on the bench and clinically, from the pharmaceutical companies and so forth. COVID is already, you know, there's activism everywhere. Well, I wouldn't call it activism, sort of activism. It's politicized already. Very confusing. Again, I think I'm watching a tennis match. And but they've certainly got our attention, the world's attention. And research is starting because everybody wants the golden ring, right? First to the finish line, first to get the vaccine, first to get the drugs, the winner. So many mistakes have been made already. And then there's plenty of money coming in. Look at what the government's doing with the effect on our economies in the U.S. and other economies around the world. Let's come down to Lyme Borreliosis complex, which is neck and neck with COVID in terms of the number of people infected, involved. And again, we don't know if COVID's going to be persistent, chronic, recurrent. Strains are going to change. Mutations are already occurring. When's the vaccine coming? Not soon, and so forth and so on. So Lyme activism, I'm going to put a check mark there, even though it's been a little dysfunctional, a lot dysfunctional. Until recent years, it's getting better. We have 2 or 3 solid groups who don't care who gets the credit. And prior to that, it was everybody was, let me get the credit. I need the credit. I did all this. And research, nah, not so much. Money, nah, no. There's no money. So Lyme Borreliosis is like 25, 30 years behind HIV/AIDS in terms of not only time, but also funding. So hope you enjoy that. One of the, as we go to the next slide, here's what Sinai and I discovered. And I asked him to look into this because I was understanding the pathology or micropathology of COVID. Now, this is in advanced cases. So this is not, if you get a mild cold or a mildly symptomatic disease. But some of the really smart intensivists around the country noted that, hey, this is not adult respiratory distress syndrome. It looks different. The lungs aren't wet and boggy. We're seeing patchy infiltrates, and then on pathology, and those who unfortunately died, they're seeing a lot of microvascular infarcts, and the same thing in the brain, and the same thing throughout the body. What the heck's going on? So COVID is a dirty little devil here, because what it does is it turns on a molecule in the thrombophilic system, the thrombolytic system. So everything's in balance in our body, right? So we make clots so we don't bleed. We break down clots so we don't clot off and, you know, have vascular infarcts. So everything's in balance. And some of the key players are TPA, which is plasminogen, and urokinase to break down clots. And then there is a procoagulant called plasminogen activator inhibitor. And it turns out that is elevated in COVID, and therefore it's a procoagulant, makes clots, which makes sense. And then on top of that, you've got, I'm sure, intravascular infiltration and inflammation. So people start clotting. and they start having microinfarcts. That's what happens in the lungs and the brain and other places. We found out, I said, hey, let's go look at an old drug that we used, which is a fibrinolytic, breaks down fibrin. It's derived from soybeans through enzymatic changes by a bacillus species. And there is a non-soybean derivative, by the way. That's called nattokinase. And by golly, we found a couple articles in the last 5 years, scholarly articles. And we drew the graph from one of these articles that says that nattokinase is probably effective, or is effective in terms of inhibiting PAI1. And I love this because nattokinase is such a benign product, safer than aspirin. And I've used it in the past. I used to use it for biofilm way before I started with xylitol. And the reason I used it is I knew it was mild. And at that point, since I didn't have a reliable way to break down biofilm, I didn't want to unleash everything on my borreliosis patients. So I said, I'll just do something mild. We'll just sort of plod along until I figure it out. So we use nattokinase. We still use nattokinase in some of our infusion patients to help keep the lines open, so you don't get fibrin collection in their catheters. Very excited about this, and this is the contribution I'd like to propose that we make to our Lyme borreliosis patients, and that is to add nattokinase to your cocktail, which consists of quercetin, zinc, vitamin C, vitamin D, etc. I think it's perfectly safe unless you have a bleeding issue, and it inhibits the PAI1. So we're very excited about that, and this is one of the 2 discoveries that we made just in the last month or so. Moving on to our next slide, we talk a little bit more about the cocktail, and this was another question, is what can somebody do? Obviously, immune strength is most important. Now, if you've been treated here and you're a couple years into therapy, your immune system's probably okay, or getting better. We're going to know a lot more about that as I work with GLA to do the first ever observational trial, because we're going to be measuring biomarkers, immunologic markers, and so forth. There's a lot we don't understand. But the cocktail that we've listed here is fairly consistent with what everybody else is recommending. If you want to take some omega-3 with it, that's fine. If you want to take some curcumin, I'm good with that as well. But I've added nattokinase at the top to this, and for that reason. And I hope you find this helpful. And that concludes our slide presentation. I thank you very much for the privilege of having a discussion with you, and I look forward to your questions.